Hello and welcome to Maths with Mr Amison. In this episode I'll be talking about rotational symmetry. Rotational symmetry is about how many times a shape looks like itself in a full 360-degree turn and is different to lines of symmetry. Lines of symmetry was the opposite of rotation, and I would recommend watching the video shown in the link here first before you look at rotational symmetry. To start off with, I'm going to give you these examples. If we want to do rotational symmetry, we need the order of rotation. So in these three shapes here, what you could do, you could get some tracing paper, trace your shape, and then do a dot in one of the corners. And then rotate the tracing paper around until the shape looks exactly like its starting position. And we see how many times it looks like its starting position in a 360-degree rotation. In this case, once, twice, 3 times, 4 times. So the square here has order 4 rotational symmetry. For the rectangle, we could do the same thing. Trace the shape, put a dot in the corner, and you can see that it looks like its starting position 2 times in 360 degrees. Therefore, the rectangle has order 2 rotational symmetry. Notice that when the shapes get back to their original starting position with the dot in the same corner, the top left, that counts as one of the times it looks like itself. So any shape will have at least order 1 rotational symmetry, because at the end of the 360-degree turn it will look like its starting position. So order 0 is impossible. So for the right angled triangle here, we trace it, draw a dot in a corner. As you rotate it round, it only looks like its original position once in that 360 degrees. Therefore, we have order 1 rotational symmetry. So find the order of rotational symmetry of each of the above shapes. Pause and have a go. So the yellow regular pentagon, the key here is it's regular. If we rotate this shape, it looks like itself 1, 2, 3, 4, 5. It looks like its original position 5 times in a 360-degree rotation. Therefore, it's order 5. The octagon, 1, 2, 3, 4, 5, 6, 7, 8. So an octagon is order 8, which makes a lot of sense because 5 identical sides and identical angles, order 5. 8 identical sides and identical angles, order 8. The scalene triangle, however, does not look like its original position until it's completed its full 360-degree turn. Therefore, it has order 1 rotational symmetry. If the shapes are irregular, then the order of rotational symmetry is not quite the same. If we have this irregular pentagon, as we rotate it, it doesn't look like its original position at all until it finishes its 360-degree turn. Therefore, it's order 1. The shape here, the interesting octagon, when we rotate this shape, it looks like it's in the same position 2 times, therefore it's order 2 rotational symmetry. And finally, for this irregular hexagon, we have order of rotational symmetry being 2. We can also shade in shapes to check, to give things orders of rotational symmetry. So if we wanted to give this shape order 3 rotational symmetry, we would need to shade in certain triangles on the grid. have a go, and I'll go through the answers. So for shape X, the triangles we need to shade in are these triangles here, because then as we rotate, this would become here and this would become here, so it would look like its original position 3 times. For shape Y, to give it order 2 rotational symmetry, by shading in 1 extra square, we have to shade in this square here. To shade in 3 extra squares and give it order 4 rotational symmetry, we would need those 2 squares there. And if we wanted to give it order 4 rotational symmetry by shading 7 extra, there's a number of ways of doing this. These 4 squares extra here, which gives 7 extra squares, or these here, or these here. If we're given these here, we want to shade in 3 more so that it has rotational symmetry order 2 and 2 lines of symmetry. The obvious way of doing this is this here, but there's more than one way to answer this question. See if you can figure out another way to answer that question. So Alan here says a square has 4 lines of symmetry and rotational symmetry of order 4. A rectangle has 2 lines of symmetry and rotational symmetry order 2. So all shapes have the same order of rotational symmetry as the number of lines of symmetry they have. Explain why Alan is wrong. So the main way we can explain this is by drawing a shape. If I draw this shape that we saw earlier, this does not have any lines of symmetry. However, it has order 2 rotational symmetry. So that clearly shows that all shapes do not have the same order of rotational symmetry as the number of lines of symmetry that they have. Plus you could draw any scalene triangle that has 0 lines of symmetry, yet it has order 1 rotational symmetry. I'm going to leave you with this. Write down the order of rotational symmetry of the quadrilateral shown in the diagram. Thanks for watching. Keep practicing rotational symmetry and lines of symmetry, and until next time, have a good day.